Okay, everybody, it is about a minute after 10, so I think that gives us a good place to jump off and begin our presentation this morning. I'd like to welcome you to the March edition of the Minnesota Toward Zero Deaths Traffic Safety Hotdish presentation. My name is Mike Hansen, and I have the privilege of serving as the director for the Department of Public Safety's Office of Traffic Safety, and I also serve as one of the 3 co-chairs for the Minnesota TZD program. I'm excited to be part of this morning's presentation, and I'd like to give a big shout out and a thanks to those agencies and entities who are sponsoring today's event and make it possible. The Minnesota Department of Health, the Minnesota Department of Public Safety, the Minnesota Department of Transportation, and of course, our partners at the National Highway Traffic Safety Administration. So all of these entities come together and make today's event possible. For your information this morning, the webinar is being recorded and it will be posted after it's complete. All attendees have been muted. PDFs of the PowerPoints will be available after the presentation concludes, and professional development hours forms will also be available and can be found on the TZD Traffic Safety Hotdish webpage, and you can see the link shown for that below. And again, we will have all of that available for everybody at the conclusion of the presentation today. So the part of the traffic safety hot dish benefit is we get to talk about the topic at hand today. So please share ideas with all participants and let the panelists know when you need or if you need technical assistance using the chat box. If you have questions for today's speaker, we please ask you to use the Q&A box, and then we will get to those at the end of today's presentation. Today, we are very pleased to have Mr. David Aylor joining us this morning to talk about advanced driver safety systems, or advanced driver safety assist systems, depending on how you want to look at it. For any of you who have bought a new car in the last couple of years, whether you know it or not, chances are that vehicle has one or more of what are considered these driver assist systems, whether it's adaptive cruise control, automatic high beam headlights, lane keeping assist, even in some circumstances, vehicles that can handle some of the steering on their own. These systems are becoming much more prevalent and in many cases are becoming standard equipment on new vehicles that are on the road out there. What is unknown is how drivers interact with these, and do these assist systems really function the way that they're intended and the way that they will assist drivers in avoiding those crash situations. So as I said, this morning we're joined by Mr. David Aylor, and David is the manager of active safety testing at the Insurance Institute for Highway Safety, otherwise known as IIHS. Mr. Aylor has worked at IIHS since 2004 and has been closely involved in all of its testing programs. Most recently, he has helped to develop and coordinate the Institute's front, rear, and pedestrian crash prevention test programs, as well as the Headlight Evaluation program. Currently, Mr. Aylor's research is focusing on the effectiveness and testing of more advanced driver assist systems. Mr. Aylor has a bachelor's degree in mechanical engineering from the University of Virginia. And with that, Mr. Aylor, I am going to turn the podium over to you. Welcome and thank you for being here, and I look forward to today's presentation.
Thank you very much, Mike. Let me share my screen. Hopefully all goes well. Great. Hopefully everyone can see this. Mike, thanks again for having me. I appreciate the opportunity to sort of walk through some of the testing that we do, talk about some of the benefits of these systems. And then at the end, I'm going to talk a little bit about some of the future testing that we're looking at and research. So just to give you a little bit of background, as Mike mentioned, I work for the Insurance Institute for Highway Safety, or IIHS. and we're a nonprofit organization, and our goals are really reducing the losses that are associated with vehicle crashes, and those include deaths, injuries, as well as property damage. And we're sponsored completely by auto insurers. Our sponsors cover about 85% of the private party insurers in the US market. So all of the big names sponsor our institution. So we're located in Virginia. We have 2 offices. One of them is outside Washington, D.C. And I'm actually located at our Vehicle Research Center, which is in Central Virginia. It's a couple hours south of Washington. And that's where we do all of our crash testing. We also have 2 test tracks, including a 5-acre covered test track, which you can see sort of in the right of that bubble there, that allows us to do testing no matter the weather. And we have slightly over 100 employees. So let's just jump right in. So, one of the big questions that we started to look at, probably 10 or 15 years ago, as we started to see some of these crash avoidance features, is, are they actually preventing crashes? And we've been able to do several studies looking at, a lot of these different systems, one with our insurance data, as well as looking at police reported crashes. And so we've been able to compare, in a lot of cases, vehicles that have this technology to vehicles, the same make and model, without the technology. And what you can see here is it's great news. All of these systems are leading to reductions in crashes. And one of the bigger ones that we really started looking at earlier was what we call front crash prevention. And those are systems that use forward-looking sensors, radars, cameras, to detect an obstacle and first warn the driver through a beeping or a flashing of a light to tell the driver to brake. And then if the driver doesn't respond, with some automatic braking. And you can see for forward collision warning systems, we're seeing reductions, in the 20 to 25% range. And then when you add automatic braking on top of that, you can see that we're cutting front to rear crashes by about 50%. And so because of that, we really wanted to promote these technologies. And so we developed a test looking at these. And here's some video. You can see we have a target that looks like a car. You can hear the warning, and then the vehicle automatically applies the brakes. And so when we developed this test, we wanted to give credit for systems that had warning, as well as more advanced systems that were able to at least mitigate, or in some cases completely avoid. And for crash testing, we had always given ratings of good, acceptable, marginal, and poor. But for these, we recognized that, any system is better than nothing. And so we came up with this rating scale of basic, advanced, and superior. Vehicles that earned a basic rating were systems that had at least a warning. And then systems that had some auto braking that either avoided in one of our test speeds of 12 or 25 miles an hour, or significantly reduced the speed, at least got an advanced rating. And we saved that top category of superior for vehicles that were really avoiding both of those speeds or substantially reducing the impact speed. And so here's some examples. Some early Volvo systems that had city safety were designed to avoid at a low speed. We had other vehicles that, they mitigated significantly. And then finally, this early Subaru system was able to completely avoid at both 12 and 25 miles an hour. So we had a wide range of performance, and we wanted to sort of give credit for all of those. Now, again, another good news story here is that we've been testing these systems for 9 or 10 years now. And when we first started evaluating these in 2013, you can see that very few of them were receiving our top rating of superior. And in fact, about 70% of the vehicles we tested, and that's about 200 models a year, didn't even have a system available. And as the years have gone on, you can see a pretty significant increase in the number of vehicles that were earning our top rating of superior. And in fact, for the 2021 model year, you can see over 80% of the vehicles had a system which earned a superior rating. And in fact, most of those are avoiding the target at both test speeds, which is really encouraging. Another thing we wanted to do was encourage these features to be standard. Often these systems, they started as optional features, and it was very difficult for consumers, to figure out what systems they were on. And so we actually, in 2016, worked with NHTSA and most of the automakers, and we came up with a voluntary commitment where all these manufacturers agreed to make auto braking standard by September of this year. And that's on all their vehicles. And that covers 99+% of the US market. And we've seen, again, with the ratings, we've seen an increase of these systems, but we've also seen an increase of the systems going from optional to standard. And even 2 years ago, we saw that 10 of the automakers had already fulfilled their commitment ahead of that pledge. And in fact, you can see there were a couple manufacturers that even, were at 90 to 94%, a couple that were over 50%. And so very quickly manufacturers responded. And now AEB, or autonomous emergency braking, is basically a de facto standard. I think most Toyotas, most Hondas have it. And again, we're seeing it, very quickly become a standard feature. One of the other areas that we've looked at is forward collision warning and autonomous emergency braking for tractor trailers. And if you remember in the graph I showed earlier, we're seeing about a 40 to 45% reduction in vehicles equipped with this technology. And we don't normally test these vehicles. We evaluate sort of passenger vehicles for consumer ratings, but we have done some testing looking at these systems. And this was a test we did at our covered track, looking at a vehicle with AEB. This was a fun demonstration. So clearly you can see the benefits of a system like that for cars as well as tractor trailers. So another system that we've evaluated over the last few years is rear automatic braking. And this is a system that's tied into the ultrasonic sensors, the small little round sensors you're used to seeing on the back of the car. Many of us are used to getting the beeping warnings as we back up. And this is a system that goes one step further. If the driver doesn't respond to that beeping, it actually can automatically apply the brakes. And while this crash type, isn't resulting in a lot of injuries or fatalities, these crashes occur all the time in our driveways, in our parking lots, and they can still be quite expensive. And you can see there that we're seeing almost an 80% reduction in backing crashes for vehicles that have automatic braking combined with rear view cameras and parking sensors. And so we actually work with some organizations around the world to develop some testing. Looking at these systems, we had backing crashes, whether you're backing up in a parking lot or into a space, even towards a fixed pole. And here's what that testing looks like. And so again, we use the same rating scale of basic, advanced to superior. And again, all of these are beneficial. And we saved the basic category for vehicles that have parking sensors or rear cross traffic alert, and then reserve the advanced or superior for systems that are actually able to automatically apply the brakes and avoid or mitigate many of the crash scenarios that I showed you. And again, as I mentioned earlier, this isn't often an issue of injuries, but low speed parking lot crashes can result in significant damage. So here's a demonstration that we conducted at our facility to show the benefit of rear auto brake. This is at 5 miles an hour. And you can see at 5 miles an hour, you can quickly build up a lot of damage. It's a $3,500 claim, whereas the automatic braking was able to avoid that. And so again, a lot of hassle, a lot of repair that would go into that. So the next test that we conducted, I'm going to talk about, is our headlight evaluations. And I just want to point out, often headlights are a forgotten safety feature. You know, without them, it makes it very challenging to drive at night. We've probably all been in vehicles that we thought had great headlights compared to vehicles that we thought had terrible headlights. And so several years ago, we started looking at the headlights. And, you know, why are headlights important? And it's pretty basic. I mean, driving at night is 3 times riskier than driving during the day. I mean, if you look at this pie chart on the left, you can see that most of our miles driven are during the day. But when we look at fatalities, over half of the fatalities are occurring at night. And we also see that about 3/4 of the pedestrian and bicyclist fatalities happen at night. So clearly that's an area where headlights can have some influence. And so early on, we looked at the benefits of headlights. And one of the technologies that we saw showed promise was what we call curve adaptive headlights. These are the headlights that actually move as you turn the steering wheel to help the driver see, you know, around and through a corner. And no matter what manufacturer we looked at, we saw benefits in reducing property damage crashes or collision crashes. And in fact, when we, you know, rolled those all up, we could see that we were reducing these nighttime crashes by about 5%, which is pretty significant. And so we wanted to see why that was. And so we started looking at some human factors experiments that established a link between the visibility and how the driver could recognize. And so we ran some tests at some roads in Central Virginia, set up some targets on the side of the road, and the drivers would actually hit a button when they saw those targets. And we saw differences between headlights and the visibility. And one of the problems that we see right now is that the federal regulation allows for a wide range of on-road visibility. And so they control the output of headlights in a low beam area and a high beam area, but that's on a fixed device like this. And once the headlights are actually mounted to the vehicle, that can change. They can be pointed, you know, low towards the ground, or they can be pointed higher up, causing glare. And so we developed you know, one of the world's first dynamic headlight evaluations. So this is an overview of our test track. We drive the vehicles on a straightaway at 40 miles an hour. We also drive the vehicle through 500-foot radius curves at 40, and then we have a more shallow curve at 80-foot radius with 50-mile-an-hour speeds. And at the end of each of those, we have a set of light sensor arrays to measure the illuminance at those curves. And here's what those arrays look like. And not only are we measuring the visibility at the edge of the road, we want to make sure that the driver can see as far down the road as possible, but we're also evaluating the glare for oncoming cars. We recognize that glare is an issue, and we want to make sure that the manufacturers produce vehicles you know, that have a lot of visibility at the edge of the road, but doesn't produce glare for oncoming cars. And so that glare stand, it's the one in the middle of the screen, is actually measuring glare at the height of a driver in basically a mid-size vehicle. And here's what that testing looks like. So this is our test driver in the car. Again, we conduct these at night on our test track. It's pitch black. And so this is a video of him running the curve. You can see him sort of driving through the curves. There's our light stand at the end. And after he does the left-hand curve, he, you know, goes through the right-hand curve. and we evaluate again the visibility and glare for those vehicles. And so early on, when we started this in 2016, we started with mid-sized cars. And one of the challenges with headlights, as you may be aware if you've purchased a vehicle, is that many of these vehicles offer 2 or 3 different types of headlights. And so you can see here, we evaluated 31 mid-sized cars in 2016. That was actually 82 headlight variants. We evaluated small SUVs, pickup trucks, as well as mid-size SUVs. And we continue to evaluate these headlights. And I'll talk a little bit about this. And we were unsure, how many people would be interested in these releases. And these were actually some of the more popular releases because I think people recognize that their headlights are good or they're not good. And so here are some of the news stories that were associated with these headlight releases.
The group tested 21 small SUVs to rate their efficiency of their headlights. It turns out not a single vehicle ranked in the good category.
A new report this morning criticizes the performance of headlights on most pickup trucks. The Insurance Institute for Highway Safety looked up 11 pickups equipped with 23 different headlight options. It found just one earned top marks.
The insurance industry recently began testing headlights on cars and trucks, and it is not a pretty picture.
A new study out this morning shows many mid-size SUVs struggle to light up the roads at night. The Insurance Institute for Highway Safety looked at headlights on 37 different models. Chris Van Cleve is in Washington with the disturbing test results. Chris, good morning.
Look closely. Can you spot the person crossing the road? They're virtually undetectable in these headlights on the Kia Sorento, which ranked among the worst of those tested by the Insurance Institute for Highway Safety.
So again, this is another positive news story. We have seen lots of improvements since we first started testing. And so, when we look at the last 5 or 6 years, first of all, when we look at the best rated headlights on those models, so if a model offers 2 or 3, this is the top rating. And again, we evaluate these cars based on their visibility and glare, and we give them ratings. Our top rating is good, then acceptable, marginal, and our lowest rating is poor. And when we first started testing, you can see very few vehicles even offered a good rated headlight. And in fact, about 50% of them, the best headlight was poor. Now flash forward 6 years, and you can see that now about 50% of the 200 or so models we evaluate at least offer a good headlight. And about another 30% offer an acceptable headlight, which is great. Unfortunately, when we look at all of our headlight ratings, you can see that the picture changes a little bit. Again, very few vehicles had good ratings in 2016. But now when we look at all the headlights, multiple headlight variants for the different models, you can see about 30% get a good rating. And that's about similar to the poor. And so one of the challenges is often these better rated headlights are offered on the top trims or optional packages. And so it's extremely challenging for consumers to find good headlights. And we encourage consumers to use our ratings or even test drive the cars at night. That's not something that most people do when they buy a new car. And I should point out another thing that we're trying to do is through our Top Safety Pick Award, which looks at crash test ratings as well as all the safety features, is we're trying to encourage manufacturers to equip these technologies on all of their vehicles so that consumers don't have to really shop around or pay attention to what trim they buy. So just getting into this a little bit, how are manufacturers improving these ratings with their headlights? And they're doing that 2 ways. As I mentioned, we look at glare, we also look at visibility. And so you can see we've seen a decrease in glare, and we recognize this is a problem. A lot of people have issues with glare. And when we first started testing, we have sort of a limit to the glare that's allowed. And you can see if we averaged all the low beam glare by model year, early on, the average glare was over our threshold. Even for 2017, it was over that threshold. But that number has continually gone down. And so now when we look at the 2021 model year vehicles, you can see that most of the vehicles are well below the glare limit, and the average is about 10%. We do still see issues with glare. It's a bigger issue on larger vehicles, pickup trucks that have their headlights mounted higher, and there is a large number of SUVs and pickups in our fleet, and so that is challenging. And just to give you a comparison of what that looks like, here's a Ford Edge that had a poor rating based on glare compared to a Ford Bronco Sport that got a good rating and had no glare. And again, this is in the low beam scenario, so you can really see there the difference in those vehicles. And we've all experienced, vehicles that we thought had higher glare or maybe had their high beams on. I should also mention that our test does also take into account high beam assist, and we weight the ratings. High beam assist is a technology that uses the forward-looking cameras and will automatically switch between the low and the high beams based on the presence of other vehicles. And so manufacturers are starting to equip more vehicles with that technology. So another way that they're improving their headlight ratings is by increasing the low beam visibility. And so again, when we look at all the low beam distances by model year, early on the averages were quite lower. We saw that about 180 feet was the typical visibility, and that number has steadily increased to now we're seeing average visibility about 210 feet. And this is encouraging because this is 30 feet more time for a driver to see an obstacle, to apply the brakes, to respond to something they may not have seen before. And so here's an image. I think we saw this in one of the news release stories, but this 2016 Toyota Prius got a good rating in our test compared to a BMW 3 Series that got a poor rating. And so you can see there in the image on the left, you can slightly make out the legs of the pedestrian and the deer targets. They're about 200 feet away. And again, that's about where that average is that we're seeing now. Early on, we wouldn't have been able to see the deer, and it would have been more like the image of the 3 Series on your right. Again, the deer are in that image. You just can't see them. And again, you're not going to be able to recognize the deer in the road or the pedestrian that's walking out in front of you. So as I mentioned, manufacturers are quickly responding to this test, and not only by improving the aim of the headlights at their factory, but they're conducting these tests and they want to do well. They want to have headlights that do well, that reduce glare and increase visibility, but they also want to earn our top safety pick. And so here's an interesting example. So Genesis brand had a brand new G80. They nominated the vehicle, and unfortunately, it got a marginal rating due to excessive glare. Genesis went back. They determined that the aim of the headlights probably wasn't what they were hoping for. So we retested it. It got an acceptable rating because they were able to reduce the glare. And in fact, not only did they make that change at their factory on new cars, but they started a service campaign. So they sent letters out to consumers that had already bought the G80 and basically told them, they said, based on the testing that was conducted at IIHS, we determined that the headlights were not aimed well enough and not focused to reduce glare. And so they asked those consumers to bring the vehicles back in so that they could fix that problem. And again, that was so that they could get that acceptable or good rating and earn a top safety pick. And here's what was on their website after we conducted the testing. Again, they highlight that this earns an IIHS top safety pick, again, which looks at headlights, it looks at crash avoidance, it also looks at the crash test ratings. So when we develop a test, we always look at the real world data. We look at, nighttime fatalities and issues there, but we always want to go back and say, are the tests that we're developing driving meaningful changes? And so recently, I think the fall of last year, we were able to look at a study at the nighttime crash risk relative to poor rated headlights. So the baseline here is poor rated headlights. are better headlights reducing crashes at night? And the answer to that is yes, no matter how you look at these. So whether we looked at all crashes or crashes with animals, driver injury, pedestrians, or even towaway crashes, you can see that we saw some benefit for marginal rated headlights. The benefit increased for acceptable rated headlights. And you can see good rated headlights versus poor had even more benefits. And so this was encouraging. This is a sign that our test is driving meaningful changes. And so we're going to continue to push manufacturers to install headlights that earn good or acceptable ratings for their consumers, because we are seeing these reductions again in all these crash modes. And so that's encouraging. And again, it's something we always do as our, as researchers. We look at the real world problem. We try to develop tests or look at sensors or technology that addresses the solution, and then go back and say, is the test doing a good job at driving change? So another area that we started looking at recently was pedestrian injuries and fatalities. And unfortunately, when you look at statistics over the last, 50 years or so, we did see some decline in pedestrian fatalities, and they reached a low in about 2008. But over the last 10 or 12 years, we've seen a significant increase in pedestrian fatalities. In fact, they've increased about 60%. And each year, over 6,000 pedestrians are killed on US roadways. And so we've done several studies. One of them looked at, why did we see this upward trend? Some of it was looking at where the crashes are happening, increased crashes in urban areas or arterials, so roads that are connecting roads. We also saw a lot of these are happening at non-intersections. These are pedestrians that are crossing, outside of crosswalks. And then clearly we've seen a pretty big increase in pedestrian fatalities at night. I'll also highlight, with the increased popularity of SUVs and trucks, that affects headlights, but it also affects the risk of injuries to pedestrians. We're also seeing an increase in vehicle horsepower. It's not uncommon now to have a typical midsize or small car with 200 plus horsepower, and that increased risk to pedestrians. So in 2018, we began looking at, how effective the front crash prevention systems, these autonomous emergency braking systems, are at preventing crashes with pedestrians. We have a system that you can see here. It's a belt and sort of driven system with a little surfboard that we can mount pedestrians to, and we can actually pull them across in front of the vehicle. And so we decided to evaluate vehicles in sort of 3 different scenarios. We have an adult walking from the right side of the road. This is the situation where an adult sort of steps out in front of traffic. The pedestrian speed is an adult walking speed, which is about 5 kilometers per hour. The vehicle, it's about 3 miles per hour. The vehicle speed, it's traveling at 20 or 40 kilometers, which is about 12 or 25 miles per hour. And if there's no braking, the impact point would be about 25% of the vehicle width. So about lined up with the center line of the passenger seat. We also have a challenging scenario that represents a child running out from the right side of a car. Again, same test speeds. In this situation, a child pedestrian running speed is about 3 miles or 5 kilometers. And in this situation, because it is more challenging, if the vehicle doesn't apply the brakes, the impact location is at the vehicle center line. The last scenario we have is a stationary adult. It also simulates sort of a pedestrian walking along the edge of the road. We see these scenarios happen on streets or roads with higher speed. So this is actually at 25 and around 37 miles per hour. Again, this impact location is about at the 25% point. And so we did some early releases. We started looking at small SUVs. And what we saw here is we saw a range of results. We did see some vehicles that earned our top rating. A handful of vehicles were advanced. And there were some vehicles at the bottom that claimed to have AEB systems that got no credit or only had a basic rating. Later that year, we looked at mid-sized cars. You can see this is a fairly large class. And again, we did see some vehicles that performed well. But at the same time, we did see a lot of vehicles that had no credit or got a basic rating because they really weren't reducing the speed significantly. But in 2 years since we first started testing this, we've seen some improvements. So in 2019, when we first started, you can see that almost half of the vehicles, didn't have a front crash prevention system that recognized pedestrians, and only about 20% earned our superior rating. But in just 2 years, we've seen a significant increase in systems that have pedestrian AEB, and even systems that earn our top rating. Almost half of the vehicles now earn our top rating of superior. So that's encouraging. But what's even more encouraging, again, we always go back and look at the real world data. We're seeing that these systems are reducing crashes. And we've done a couple studies. The first one we did was with our insurance partners. We looked at Subaru eyesight systems that are able to detect pedestrians, and most of them earn a superior rating. And we looked at crashes that were pedestrian-related insurance claims. And basically, those were claims that had an injury outside the vehicle with no damage. And we saw that those type of crashes were reduced by 35%, which is a significant number. We also did a similar study looking at the effects of AEB with pedestrian on police-reported crashes. And again, we saw similar reductions, not only on pedestrian crashes, but crashes with injuries or serious regular injuries or serious or fatal injuries. And again, we're seeing reductions at around 30%. And so that's really encouraging. Again, that means we need to continue to push these type of systems for manufacturers to install them, especially as standard features. But one of the drawbacks that we're seeing in this is, these systems are addressing daytime crashes, and that's great. And we know that most of the crashes, when we look at all crashes, about 60% of them are occurring during the day. But when we look at fatal crashes, the numbers really change. And in fact, now it's sort of a split by thirds. We can see that when we look at fatal crashes, about a third of them are still happening during the day, but about a third of them now are happening in complete darkness. And then another third are occurring, in dark situations at night when there is street lights. And so we wanted to start focusing on that. And another thing we noticed is when we looked at the effects of the pedestrian AEB on the pedestrian crashes by light condition. Again, this gold or yellowish bar here, those are the roughly 30% reductions that we're seeing. But when we look at, dark and lighted, we do see some reductions, but it's not statistically significant. But we're not seeing any reductions in these types of crashes at night. And again, they're not statistically significant. But we want to now focus on conducting these AEB tests at night. And so I'll just show this picture again. We can't forget that, one of the systems that can help is headlights. Not only can they help the driver see the pedestrians better and warn them, but they can also help the pedestrian AEB systems. We know these systems use cameras to help detect pedestrians. And if you as a driver can't see them, the camera's probably not going to be any better at seeing them as well. We just know the cameras are always paying attention. And again, I'll highlight this again. We do know that headlights can have an impact on helping see pedestrians, and we can reduce crashes with pedestrians with better headlights. But we also think that these AEB systems can help. And so we decided last year to start looking at pedestrian crashes at night. These are the same 3 scenarios that we run during the day with the adult crossing scenario, the child crossing, and the parallel adult. But again, now we're running these at night. We are running these at night under our covered test track, so we can take out any influence of the moon or clouds, and we're running them in complete darkness. And here's what that looks like, and you'll be able to tell it's completely dark. So here's the child scenario. Now this is the stationary adult. You can see it's challenging to make that out. And here's the crossing adult. And you can see, in fact, in this scenario, we did have impact. Here's the onboard, and you can see, even if you're paying attention, that pedestrian comes out very late. It's very challenging for the driver to recognize that. Now, not only do we have to consider different headlight variants and their visibility, but we also have to evaluate the low beam and high beam. And as this video plays, I want you to pay attention. It's much easier to make out the stationary pedestrian in this high beam scenario, you know, to us as a driver, but you'll also see the impact on how the AEB performance is different between these. So you can make out the pedestrian a little bit at the top, but it's very difficult to see it in the bottom. And in fact, with the high beam, this system is able to avoid, whereas with the low beam, we get no avoidance. So we did some research on vehicles, and we wanted to test vehicles that had a wide range of headlight ratings. So we had some vehicles that had good ratings, acceptable ratings. We also selected a vehicle with a poor headlight rating, and we selected that vehicle on purpose. And that's because this Toyota CHR offers both good and poor headlights, but it has the same standard AEB system. And so we wanted to compare the influence of the headlight performance on the AEB performance at night. We also wanted to look at the different AEB technology. Some of these systems use camera and radar. So you can see these vehicles here have a fusion type system that uses information from a camera as well as a radar to detect other obstacles and pedestrians. Two of the vehicles had camera only systems. We had a Chevrolet Trailblazer that has a mono single camera system. We also had a Subaru Forester that has the EyeSight system, which uses two cameras as well. And then finally, we selected a radar only system. And we, you know, the radar doesn't really care whether it's day or night. So we just wanted to see if in fact that was the case. And so let's start by looking at the average speed reductions for these vehicles during the day. And so keep in mind, this is the average for all three test scenarios, the adult, the child, the stationary adult, at both test speeds, and we're running multiple tests at each of these speeds. So 100% speed reduction would mean it avoided, you know, all of the scenarios, all of the test speeds. And you can see during the day, many of these vehicles do quite well. We're getting, you know, almost full avoidance for many of these. So what happens at night when we test them with the high beams? You can see we're starting to see some degradation in performance, which is what we would expect. But for many of these vehicles, you know, we're still doing quite well with their high beams. But we start to see continued degradation when we test these with low beams. And so again, you know, we support high beam assist for vehicles that automatically switch between low and high beams for this reason. So let me just point out a few things. First of all, I highlighted earlier the Toyota CHR that had good and poor headlights. And this was actually the top performer of this group, even for the vehicle with poor headlights. But you can see, especially with the low beam, there's some reduction in performance for that poor rated vehicle. And finally, when we looked at the radar only system of the Volkswagen, you can see there is very little difference between the daytime performance and the high and low beam. And I think some of that performance is just in noise and sort of how we conducted the test. But essentially, the performance for that radar system is the same during the day and at night. So when we looked at, you know, our pedestrian systems, what were the takeaways for this? And I think there were several. I mean, the good news is that we know pedestrian AEB systems perform well in our tests, and that's great because the data shows that AEB is preventing crashes with pedestrians. But unfortunately, we know that a lot of the fatal crashes occur at night. And a couple things that manufacturers could do to address that are better headlights, which we will continue to push, but also, you know, systems that perform better in low light or dark scenarios. And so we're actually conducting tests now with the plan to release nighttime pedestrian ratings later this year. So that's one of the big areas that we're working on for our future testing. The other thing that we're doing a lot of testing on, and this is my sort of last group of slides, is what we're calling safeguard ratings for partial driving automation. As Mike mentioned earlier, a lot of the vehicles you can buy now have partial automation that allows or has adaptive cruise control, which will, you know, maintain your speed and following distance behind other cars. But it may also have a lane centering system that can do some steering to help you stay in your lane. And right now, we're still trying to determine if those systems have safety benefits, because in some cases, the driver may think that those systems have more capabilities than they actually do. And so it's important that these type of systems keep the driver engaged in the task of driving, because really it's a cooperation between the vehicle and the driver. And so often we see situations like this.
Debate continues to rage over Tesla's controversial Autopilot feature. The electric car boasts a self-driving capability. But does that mean you should be doing this?
It is amazing. No need to drive, not a car in the world. Eating a golden burger. The zinger even tastes better with Autopilot.
Take a look at this. This video was taken last Saturday on Interstate 5 in Los Angeles by former Fresno City Council member Clint Olivier and his wife.
Hands off and start doing your makeup. Yeah. Don't worry about braking. It's got the brakes for you. Just do your makeup.
So clearly there's some behaviors there that we would like to limit. And again, these systems, most of them now are hands-on. They require that the driver's hands be on the steering wheel, and you can see in some of those videos, people are eating, people are sleeping, they're doing other tasks. And so we want to monitor that. And so about 2 years ago, we did a study looking at basically a literature review of some other industries and what we would recommend for partially automated systems. So what behaviors should be monitored to make sure the driver's still engaged. And then if the driver is not responding, or the car can tell they're not paying attention, what's the best way to get them back engaged in the task of driving? And then that study also looked at, what other capabilities should these systems have? And so we're currently looking at these safeguards and trying to evaluate them. And so first of all, I want to highlight that, we're not endorsing partial automation. Again, we don't necessarily have a safety case for that, but we want to make sure that if manufacturers put these vehicles in their car, we want to make sure that they're done safely. And so we are going to rate these systems, and some of the things that we want to look for. The first thing is driver monitoring, right? So we want to make sure that if the vehicle has these partially automated systems, that they are monitoring the driver. They're making sure that the driver, is looking at the road, not necessarily at their cell phone or doing other tasks. We also want to make sure that they're monitoring their hands, right? So many of these are hands-on systems. Their hands should be on the steering wheel. There are some newer systems like General Motors Super Cruise, Ford has Blue Cruise, that allow you to take your hands off. But what are the hands doing? They need to be able to take over quickly. So in that video, there was somebody eating a burger and somebody doing their makeup. If there was a task where the driver needed to take over, their hands are occupied. And so we want to make sure that the driver not only is watching the road, but their hands are ready to take over. And then what happens when the car recognizes that the driver's not paying attention? What kind of attention reminders do we go through? And we want to make sure that there are multiple modes of alert, whether it's visual, audible, even haptic, a vibrating seat or tugging of the steering wheel, all to try to get the driver back into the task of driving. And we want to make sure that those happen fairly quickly. Even if you have the best reminders, if they're allowing you to drive for a minute or even 30 seconds without warning you, at highway speeds, that can be, a half a mile to a mile of road that you're covering, without paying attention. So we want to make sure that not only they're good reminders, but they're happening quickly. And then finally, emergency escalation. We know in some cases, drivers become incapacitated. So how does the system handle that? Ultimately, we'd like these systems to, pull over, to come to a safe stop in a parking lot or the median or, off to the side of the road in the shoulder. But right now, that's not the case. So, do these systems bring the vehicle to a safe stop? Do they lock the driver out from using it again? And we'd also like them to, to make a phone call, whether that's to an agent or a concierge service that can address this problem, or to 911 to let them know that, this car has come to a stop. We also want to make sure that the application of these automated functions are done in a reasonable way or responsible way. Many of the features give the driver the sense that the car is in control and they can check out. But in fact, as I mentioned, this is a cooperative effort between the driver and the vehicle. And so does the driver get the sense that they're driving? Do they have to sort of acknowledge a lane change, or how is the steering cooperative? And then finally, we want to make sure that the systems require safety feature use. So if you're going to use these, we want to make sure that the driver has to be buckled or remain buckled. If they start to unbuckle, I think the last video you saw there was a driver trying to climb out of the driver's seat. To me, the oldest form of driver monitoring is making sure your bottom is in the seat and you were buckled. Unfortunately, we've seen some systems that allow these, partial automation systems to be engaged when the driver's unbuckled. So for us, that's a pretty obvious one. And also, we know these systems aren't foolproof. And so we want to make sure that when the driver is activating these, that the safety features that we know have real world benefit that I showed you at the beginning of this presentation, like autonomous emergency braking, like lane departure prevention, remain on and engaged when the driver activates these features. And so again, this program is not endorsing the partial automation, but we also want to grow as different systems become available. And so again, we're going to rate these safeguard programs like our crash testing: good, acceptable, marginal, or poor. So, we want to see manufacturers do things, to promote safe use, and those type of systems will get a good rating. We're currently working on the protocol. We want to go through lots of different scenarios and see how these systems perform. And our plan, again, is to sort of work on the protocol, look at some of the vehicles that we have, not only the high profile systems like Tesla's Autopilot, General Motors Super Cruise, Ford's Blue Cruise, but a lot of the systems that have lane keeping or lane centering and adaptive cruise controls, on Hondas and Toyotas and other mainstream vehicles. And we're hoping that, later this year, towards the end of this year, we'd be able to come out with a first set of ratings for consumers to look at, but also to help guide the manufacturer in their design of these features. And so that's our plan moving forward. And so with that, I see that I have a few questions. So I'm going to open it up for some questions, and we have a little bit of time here to answer any of those questions.
David, thank you so much. That was just an absolutely fascinating presentation. And my hat's off to IIHS. I mean, you guys do some incredible work. A couple of years ago, I was privileged to be able to visit your facility there in Virginia and tour it, and then actually witness and participate with one of your crash tests. Fascinating technology. Anybody on the webinar that gets the chance, I highly recommend you take the opportunity to visit there. Shortly, you're going to see a QR code pop up, folks. And before I get to questions, just really quickly, if you could take your smartphone and activate that QR code. We have just a real brief survey. We would really appreciate it if you'd complete that for us. And that helps to kind of guide our discussions for our future Hotdish topics. So thank you very much. While everybody's working on that, David, there's a couple of questions specifically related to, and being in the land of Minnesota and two seasons, winter and then the good season, visibility, winter weather, snow, how does inclement weather and reduced visibility and all the stuff and the gunk that accumulates on these sensors, how does that affect the way they work?
Yeah, that's a great question. So first of all, several years ago, we did some testing. We don't get a lot of snow in Virginia, but we got some snow, and we took the opportunity to go out and see how some of these systems performed in the snow. And what we found, again, this wasn't, the car caked in ice and snow. I can touch on that. But what we found was that the systems, they still warned and they still applied the brakes. but they were at the same time as during dry conditions. And as you know, most of us hopefully know, we're taught, in those conditions of snow and ice, to give, more following distance because it's going to take longer to brake. And so we still got the braking, but we actually had impacts again because of the lower friction on the road. Now, one of the things as we move towards more autonomy that manufacturers are going to have to work towards, right? They're going to have to avoid crashes in good weather, but they're going to have to avoid crashes in bad weather. And this is one of the reasons why a lot of these companies are testing in Phoenix and in San Francisco, right? The weather is the same most of the year. But there are systems on the vehicle, they can tell if the windshield wipers are on, which should imply, the road surface is wet, or vehicles have traction control that can tell, oh, the surface is slipperier. And so I could see, nobody's doing this now as far as I know, but I could see manufacturers taking all of that information and saying, I recognize the road is wet. So I need to maybe warn the driver earlier. I also need to apply the brakes earlier in order to avoid this. So there are ways to address that. To the second part of your question about sensors, we have seen situations where, radar sensors mounted on the front of the car, if they get covered in ice and snow and debris, can tell the driver, hey, I'm not currently working. And that is a challenge. Same thing with your windshield, right? If the camera's covered. And again, there's a lot of talk about autonomous vehicles, tomorrow. And these are a lot of the issues that need to be addressed before we get there. And so those are challenges. And I think we're going to need multiple sensors to have sensor redundancy to address these problems. And so that's a great question.
No, and thanks for that, David. A couple of questions from Q&A. Have you tested headlights for driver reaction using taller and darker roadside targets that would better approximate a deer or a pedestrian in those higher platform vehicles?
Yeah, so some of that gets at the pedestrian testing that we've been running, and it is always a balance between the visibility and the glare. And so we have looked at that. I will also say one of the advantages of the high beam assist, which automatically switches between low and high beams, is that it really gives you high beams, as frequently as you can use it. And then it will turn to low beam when other cars are around. I should also point out another technology that is getting a lot of interest now is what's called adaptive driving beam. And this is a technology that's been available in Europe for many years. But because of the way that the federal headlight standard was written, it wasn't until recently allowed. They just allowed it. But what this does is it basically uses more advanced headlights that have multiple LEDs, and your high beams are on all the time in all the areas, but it uses the same camera, and it can turn off just a handful of the LEDs to sort of shadow out oncoming cars or lead vehicles. And so you would have high beam in all the areas except where you need to limit glare. And so we think that technology has a lot of promise if it's implemented correctly. So instead of having sort of high beams or low beams, at one time, you basically have high beams all the time with small areas of low beam. And so we're big proponents of that, and it would help, light up deer on the side of the road or pedestrians at the edge of the road, but still limit glare to other vehicles. And so that's a technology that's coming. Again, part of the infrastructure bill that was written basically asked the federal government to include that or allow it. And they recently came out with a rule maybe a few weeks ago that would allow that.
Great, thanks. For all of our law enforcement partners on the call, these technologies, while they're great and they are preventing crashes, some of the reading that I've done, there's an area of concern, and it's kind of twofold. Number one, a lot of drivers don't really understand how to interact with these systems. And when they don't have that education or that understanding, there's the disengagement factor where they actually turn them off, which in some cases can make things even worse. Any hints for how law enforcement can take a look at or further explore this? And for the law enforcement officers on the call, it's not like we're going to greatly expand that crash report you already have to fill out, but just trying to put a couple more tools in your toolbox.
Yeah, so a couple things. This first part may not address, you know, how law enforcement might do it, but we have seen, for instance, early in the study, the forward collision warning had some benefit, but the autonomous emergency braking had more. So we do recognize that the features that sort of work irrespective of the driver have more benefit. We do also think that, you know, how the feature is implemented is important. And we did some studies early on where we went to vehicle dealers to find out if consumers were leaving systems on or they were turning them off. And we found out that autonomous forward collision warning and autonomous emergency braking almost always were left on, right? That's a feature that happens pretty late. It is an emergency. You know, it's working in the background. And I think most drivers recognize, you know, when it goes off, why it went off. But we found that lane departure warning in a lot of cases was being turned off. And many of us have driven cars like that. You know, we might be tugging the inside of the lane and we know we are, and it beeps at us. We have heard anecdotal data that, you know, some people say it's embarrassing. You know, they're driving and their mother-in-law is in the back seat and, you know, it's going beep, 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 you know, and, you know, or my kids are like, Dad, you're out of the lane again. You know, the backseat driver, you know, knows that you're not driving well. And so a lot of people turn it off. And so I think there's a balance there for designers in sort of making it acceptable to the driver. But to your next point, yeah, you know, the best safety feature in the world, if it's turned off, is going to have no benefit. And so we need to make sure it's implemented well. And part of our hesitance in rating some of these partial automation is, you know, if it's misunderstood, then drivers will abuse it like those videos. And so I think it's very important, whether it's for the manufacturers, whether it's for consumer information groups, whether it's for dealers, is really making sure that consumers do understand how the systems are supposed to be used, right? The driver's still supposed to have their hands on the wheel. You know, we see commercials a lot where the cars sort of show this halo around the lane and the driver sort of takes their hands off, you know, and in small print it says, you know, closed course. And so that's misleading. Even the names like Autopilot, you know, are misleading. And so there is a driver education piece, I think, that's really important. But I think all of our organizations are trying to work through what's the best avenue to make sure the driver understands, you know, what the system's actually doing.
No, excellent points. You know, the educational part of that is also educating drivers not to be overly dependent on these. And I think you make a good point where some of these systems have been oversold, quite honestly. And again, my hat's off to IIHS for, you know, kind of being that governing factor that is pulling the safety back into this, which should be the ultimate goal. So again, just great work going on there. A couple more last minute ones. Now the presentation looked at commercial vehicles and passenger cars. How about buses or school buses? Are you aware of this technology being rolled out into that system?
Yeah, so we haven't looked specifically at that. I do know that there are some commercial buses looking at these. You know, there are buses that have sort of blind spot monitoring. You know, that's a big issue for, you know, especially city type buses as they pull away from the curbs. So that technology is expanding. A lot of that is driven by the fleets, right? And who's buying that equipment and making sure that the buses or in the video I saw, the tractor trailers that they're buying have this technology. And so, we haven't, most of our focus is on passenger cars in terms of rating. Have done some research looking at reductions in others. So I'm sure that technology is out there. And again, systems like Aeb, we think would have, extremely high benefits for systems like that. And even, pedestrian detection type systems for buses, you think in city environments where there are lots of pedestrians crossing and buses and stopping and starting, that's important. And even in cities, I think there are probably a lot that can be done in terms of design as well, right? I pointed pedestrians are crossing at non-intersections, bicycle traffic and how that interacts with buses and cars is also a way to address some of that.
Yep, very good. We've got a question from one of my engineer friends, and related to the technology that is being used. For lane keeping evaluations, are there any specific broken line pavement marking gap lengths that will be used or should be used, or that these systems as we know them now depend on that? MnDOT currently uses a 10-foot skip with a 40-foot gap. So you've got a 10-foot stripe and then 40 feet of nothing. And they're looking at reducing that gap length, which I think may prove to be beneficial. But is there anything out there that you're seeing that might dictate that gap and skip length?
So I think most of the regulations now use that similar 10-foot and 40-foot measurement. But some of the systems, even California used bots dots, for a long time. I think they're now starting to go away from that. But the federal government had requirements as part of their NCAP procedure, not only to look at dash lines and lane lines, but also bots dots. So I think the systems are pretty good at determining that as long as there's a gap. I think the bigger issue, and this is a struggle for our infrastructure, is keeping those lane lines, whatever their spacing is, maintained. We know that our roads aren't always in the best shape, or don't have lane lines in some cases. And so these systems, they're always on. They're dumb systems, but they're always on, and as long as there are lane lines for them to pick up on, they'll usually work. But again, challenges are construction where road move over, or lane lines are degraded, or in Minnesota, if they're covered in snow, right, they can't see them. A good example of road upkeep, the crash in the Tesla crash in Mountain View, some of the indications were that the lane lines were worn, and so the system was trying to determine where it should be in the road. And so I would say a bigger challenge is sort of maintaining the lane lines and keeping them well painted.
Very good, very good. Another question from Maggie. We all know pickup trucks and SUVs, those platforms are getting taller and wider and more broad in the front. And with that increase in that height, you lose that portion of forward visibility that you just can't see that falls below that hood line. Any idea or thoughts, research on how the headlight configuration applies to that or could affect that?
Yeah, that's a great question. So, I mean, if you think about it, it's sort of basic geometry, right? If your headlights are really high, in order to reduce glare to oncoming cars, you have to aim them down, which reduces the visibility. And we have seen some cases where manufacturers now are mounting those headlights lower. You can look at Hyundai has a lot of products, newer products, where their headlights are mounted lower. I think the previous version Jeep Cherokee, the headlights were mounted lower. And so what that means is that addresses exactly that concern of sort of that visibility close to the car, but it really allows you to throw visibility well down the road and prevent glare. And so I think, that's an advantage. Some of the advanced technologies I talked about, also could sort of shut off areas to help that as well. But we are seeing some designs that are lowering headlights to help that.
Very good, very good. How about aftermarket equipment for the headlights? I'll really date myself in the old round headlights that the 1197s or whatever we used to buy. And it was pretty simple, but headlights are anything but that anymore. Have you seen an aftermarket penetration start to take place?
Yeah, it's a great question. I mean, I also remember sort of, you could go to Advanced Auto and either get the round ones or the square ones, right? And they fit into everything. And oddly enough, the headlight standard that wasn't changed until recently was the same since the 1970s. So those same square halogens, round halogens, it's the same headlight requirement, but today we have LEDs and HID. So it was time for an upgrade. We haven't started to look into that as much. I mean, part of the issue is new headlights are clearly not doing as well as we would like. And so we started there. In 4 or 5 years, we've come a long way, but there's still a lot of work to be done. But there is some issues with aftermarket lights. We know some of them degrade. Some states have, inspection requirements, for headlights. Some are more detailed than others. It may just be whether they're hazed over, even after a crash, where they aim. So there are a lot of complicated challenges that sort of are hard to control with those aftermarket lights. So it's a question we get a lot, and we may look at, but right now we're focused on making sure that the new headlights that consumers get are good to start with.
Okay, got it. Got kind of a big picture question related to autonomy and some of these systems that are supposed to save us from ourselves. Ridiculous human behavior isn't specific to semi-autonomous vehicles, but how are we going to know when vehicle autonomy and the technology that comes with it is good enough for wide release? I think you touched on some of the challenges that visibility and weather really have to become overcome before wide release is going to be acceptable. But do we have any idea what are the measures of success that will build that threshold for us to cross?
That's a great question. And we could have a whole nother webinar on that. I mean, I think you hit on it. What is good enough? And unfortunately about 40,000 people a year die on our roads, right? And if we were able to say, we have this autonomous system, it's going to prevent a lot of crashes, but maybe it causes some, or maybe it doesn't reduce others, but we're able to bring that net down to 30,000. Is that good enough? I don't know. Is the public willing to accept, right now, about 94% of crashes are human error. And some of those can be addressed by safety technology. Not all of them will be, but is the public willing to accept, me causing a crash versus a computer causing a crash? And so that's a great question. And I think it's going to be baby steps, right? We're going to have to sort of, some of these technologies are addressing front to rear crashes. Some are addressing run off the road crashes. And so again, it's going to be baby steps. And it's going to be a long time before we're, full autonomy and we're handling weather and other situations. And so we can't forget about these current technologies that we know are reducing crashes and jump 40, 50 years down the road for full autonomy. But that's a great question. Probably another webinar series for you to focus on what's good enough.
Well, I think I can probably, with some confidence, tell you that you'll probably have another invitation in the mail here. I have another question from one of our attendees who does a lot of really great work with our experienced driving population. The warning methods for, kind of getting that driver to re-engage when they're overusing these systems, such as the vibrating seat or steering wheel, the beep, 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 or the other bells and whistles. Any idea if that in itself is a distraction that, and I guess I probably experienced this a little bit myself with some of the cars that I've rented, when you're not familiar with what the heck is that thing telling me to do, and you have to try and figure that out to make that annoying thing, whatever it is, go away.
Yeah, that's a great question. And there's a lot of work, human factors work going into that. Like you said, there's a lot of different age drivers, there's different strategies. And so, you know, even technology, you know, whether it's a small yellow light or big red light, you know, or how quickly it beeps, there's a lot of work and different research that points to that. Right now, we're focusing on wanting multiple warnings, right? I mean, if the driver's not looking at the road, then a red flashing light in the instrument panel is not going to do any good, right? So, or if their radio is up, maybe the beeping's not loud enough. You know, maybe pulling of the seatbelt is a good one to get you looking forward. I've even seen some sort of prototype technology that knows if the driver's looking to the passenger seat, there's a light that sort of flashes forward along the door panel to sort of get the driver focused back in the direction. So you're absolutely right. It's a big challenge, and we can meet with a manufacturer one day and they say, this is the warning strategy. It's the best one. Here's the data. Looks reasonable. We can meet with another manufacturer the next day and say, here's a totally different warning strategy. Here's the data. It looks reasonable. So I think as more of these systems get on cars, we might be able to tell, you know, the way this system's warning is better than that one, or a driver's turning this one off because it's annoying. But we're still trying to work through that. But it's definitely a concern and something we're trying to work through.
And I think that that's a great place to leave our discussion today, David. There is a lot more work to be done. And you make a great point. As much as some would have us believe that autonomy is right around the corner, I'm fairly confident we're still a couple decades away from that. And then we have all of the issues of the transition that's going to take place. Our fleet right now, I think the average age is what, 12 or 13 years old for what's on the road. So we have a lot of things that are going to need to change in the meantime. But with that, David, I just, on behalf of Minnesota Towards Zero Deaths and all of us that are involved with that, we really appreciate your time today, your expertise. This was just a great presentation, and we look forward to having you back again.
Absolutely. Thanks for having me, and thanks for all the hard work you folks are doing as well.
Very good. Thank you very much. Hope to get back down to Ruckersville again to see that facility. I really enjoyed that.
We look forward to it.
All right. Sounds good. And with that, to all of our attendees today, I would really like to take this opportunity to thank you for carving some time out of your morning to spend some time learning about another one of our important traffic safety issues and challenges and opportunities that we have as we move forward and try and improve the picture on Minnesota roads and roads everywhere for that matter. Our next traffic safety hot dish is going to take place on July 20th at 10 o'clock in the morning. So stay tuned for the announcement of that and the topic of the day for that particular presentation. Please do take a couple minutes if you haven't completed the survey for us. We would really appreciate that. And with that, I wish everybody a good rest of your day. Stay safe, dry, and warm, and have a great rest of your week. Thank you, everybody, for attending today.